Okay, so we have the periodic table that I hand you guys out, and you're going to have out the from the electron configuration orbital diagram notes this the little tool for this, right? And you've got four different colors, and so what we're going to do is we are going to create sort of like colored sections on the periodic table based on the sublevel shape, S, P, D, or F, that the last electron for that element like the last electron that element falls into. So if the last electron goes into an S, you're going to color it one color for S. If it falls into a P, you're going to color it a different color. So down at the bottom, choose your colors that you want to use for S, P, D, and F here. There's four boxes. So
Hey, Mark, do you have any extra copies of that
sheet? Hold on.
Otherwise, I can just take it. Oh, I found it.
You did? Okay.
Does it matter?
Nope, doesn't matter. Doesn't matter which one. You got four different colors, so one of them will be the S. One of them will be the P. One's going to be the D. Yeah, down here, like make yourself a key. Which block is gonna correspond with which color. So S, P, D, and F. Figure out which of your colors is it. Obviously, it's not going to be the same as mine, but color-wise. But you'll assign one color per sublevel. So everybody have their key down?
Sure.
All right, so here's what we're going to do. We're going to use this and the number of electrons to find which block the last electron goes into. So, for example, hydrogen, oops, sorry, let me get this on the screen here. Hydrogen has one electron. It's got the one electron, so that electron is going to be in the 1s, right? So whatever your S color is what you color hydrogen. Okay, now if you're going to outline stuff, I wouldn't outline each individual one. I'd wait to outline until you see where where they all are. Okay. All right. Now, the next one, helium has two electrons, right? So how many can 1s hold? Two. So the second electron, the last electron for helium is going to go into 1s, right? So that's also an S. So we color helium whatever your S color is. The same color you just colored hydrogen, you should be coloring helium. And that should match whatever your S block is here. Some people with pens were kind of just like, yeah, like just like shading on the sides or something. If you want to do something like that, you can do that too. If you don't want to color in the whole thing with it or whatever. Oh, do you want a new one? Here. If you want, that's fine.
don't have any.
Okay. Wait, did you say you wanted one of the?
Yeah.
Okay. Um, so lithium has 3. So it's going to be 1s2, and then it's got 1 left, and it's going to go into 2s, right? So its last one is 2s. So it's still an S. So whatever your S color is, we're going to color lithium. Okay.
Wait, why is it lighter?
Mine, just because I wasn't pressing as hard.
Oh, okay. I thought it was like.
No, it's not. It's not different. It's yeah, it's the same color. Same color as the other. So yeah, you're still an S. Okay. Beryllium has 4 electrons. So we got 1s2, 2s2. S's can hold up to 2, right?
Mm-hmm.
So the last one of beryllium is in an S, so that's an S. So far we've only had S's. We've only had one that the valence electrons fall in the S's. So far it should look like this. Whatever your S color is, but okay. So next one is boron, right? Boron has 5. So we've got 2 in the 1s, 2 in the 2s, and we're following the arrows. Remember, you're following the arrows. After 2s, we hit 2p. Okay, so the next one is p. So whatever your p block color is what the electron for boron falls into. Okay. Now, let me ask you guys this. How many electrons can a p sublevel hold? 6. It's got 3 orbitals, 6 electrons though, right? So the next 6 elements, because you're just going up by 1 electron each time, right? So the next 6 electrons, including boron, are going to fall into 2p, right? So you don't have to do each one individually. You can actually follow this and count. So p can hold 6, so it'll be the next 6 elements. 1, 2, 3, 4, 5, 6. So all of these will be a p because it's that 2p. Everybody understand how I got that?
Yeah.
We got 2p, which can hold 6 electrons, so it's the next 6 elements. So we had 2s, right? That was the lithium and beryllium. Okay, and then after 2s, we hit 2p. P can have 6 electrons, right? So that's the next 6 elements are going to be, their last electron is going to be in a p. Oh, you sure? All right, so everybody's good up to here so far? Okay, what comes after 2p if we're following our arrows? 3s. How many can s's hold? 2. So we're going to go with our S, and the next 2 elements we're going to color the S color. So that's sodium and magnesium, our S. Okay, so that was 3s, right? You just got to kind of keep track where you're at. Make sure you don't lose track where you're at on the thing. So we hit the head of that arrow, we go to the tail of the next one. What do we hit after 3s? 3p. 3p can hold how many? 6. So the next 6 are going to be p. So 1, 2, 3, 4, 5, 6.
So AL is
Yep. Okay, so we just finished with our 3P, correct? So after 3P, remember you're following the arrows, not like the order across. You're following the arrows. So after 3P, what do we hit? 4S. So that would be how many of those? 2. 2 in the S. So after argon, you come over here. So the next 2, potassium and calcium, are going to be S's. Okay, what do we hit? So yeah, so if we're following this, right, we were at 4S. We hit the head of the arrow and we go to the tail of the next one. We hit 3D. So whatever, now you're going to use your D color, whatever your D color is. Good. D's can hold 10. So you're going to count the next 10, and those are going to be D color. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So everything from SC to ZN is going to be whatever your D color is. Everybody following along so far? Next one, guys, is after the, so remember you're following this, right? So after 3D you hit 4P, so P can hold 6. So you do the next 6, and you just keep following the chart. So the next 6 would be in P, and you just keep following the arrows. You keep following the arrows and filling in the colors from this. Okay, now, one thing I need to point out here. When you get down here to the last 2 rows, okay, watch your numbers. Everybody paying attention? Watch the numbers. It goes 55, 56, then it jumps down here. Then it jumps down here to 57 through 70.
Because it doesn't make it too wide.
Yeah, we can't fit it all like
Yeah,
on
but like what I'm saying is, why doesn't it put the bottom part
that.
like, why does it randomly just jump out like that? It's like too long. No, I mean, but like, why didn't they show that?
All right, guys, if you're still coloring in, that's fine. I just want to I want to go over a few things here a little bit. So when you finish, it should look something kind of like this, right? And as some of you had already commented and noticed, you've got a pattern here. You've got your S block we got one kind of straggler over here. It's an S block, and then you've got your P block over here. You've got your D block in the middle, and then the F block is underneath like that, right? So this is the sublevels. You can see that the sublevels that the valence electrons fall into are kind of grouped by those areas. Now, one other thing that you might notice is our S blocks are over here, right? And the S block, or the S sublevels, are what starts each energy level. So like we have energy level 1 starts here. Energy level 2 starts with 2S. Well, here's the 2S ones. Energy level 3 starts 3S. And those are here. So each row down on the periodic table represents the start of a new energy level in the atom. The start of a new energy level, okay? Now, if you go in here and you look, like this this D block, or this D row here, this is actually 3D, but it's in the fourth row. And that's because we start the fourth energy level before we fully fill the third one here. So it kind of like backfills. But this is like the start of each new energy level as you go down. Right? So we'll use this a little more in the coming days, so don't lose this, because we will do a few things with this.